Hi everyone, welcome back to the channel. This is part 7 of the CCNA exam practice question series. I will be covering the topics and questions that will help you pass the CCNA certification exam. In this video, I have compiled a 30 practice questions to get you prepped and primed for the success on the CCNA certification exam. Besides the question and answer, we will also be explaining the concepts that will make you feel like Cisco networking superhero. So if you are ready to ace the CCNA exam and elevate your career to new heights, make sure to hit that like button, subscribe to the channel and ring the notification bell so that you don't miss any future content. So let's gear up and dive into the success. Question number 1. What is the role of access points in an enterprise network? And the options are option A, connect wireless devices to a wired network. Option B, support secure user logins to devices or the network. Option C, integrate with SNMP in preventing DDoS attacks. And option D, serve as a first line of defense in an enterprise network. So we are talking about the access point role in a wireless network. So let's suppose this is access points and we have different wireless clients. Let's suppose laptop, smartphones that are connected to this access point. So what is the role of this access point? And the correct option is that the access point connect wireless devices to a wired network. So this is the basic role. And this is how an access point is placed. So here we have an access point and the wireless clients, they connect to the access point through this wireless LAN, and then the access point is used to connect these clients to the wired network. So this is basically the wired network. Some clients may want to connect to the internet, some clients may want to use the local server. So the bridge between the wired and the wireless network is this access point. Question number 2. What is the same for both copper and fiber interfaces when using SFP modules? And the options are option A, they support an inline optical attenuator to enhance signal strength. Option B, they provide minimal interruption to services by being hot swappable. Option C, they offer reliable bandwidth up to 100 Mbps in half duplex mode. And option D, they accommodate single mode and multi-mode in single module. And the correct option is that both the copper and fiber SFPs provide minimal interruption to services by being hot swappable. So these are basically the SFPs. This is the fiber SFP, optical fiber cable SFP, you can call it. And this is the copper SFP with which you can plug the Cat6, Cat7 cables using RJ45 connector. While for the fiber here we use basically these connector. These are basically the fiber connector. They are known as basically LC connector. So they both have in common that you can plug in these SFPs into the devices while the device is in the running state and it won't interrupt any services. Hot swappable means that you don't need to shut down this device, this switch or router to plug in the device. You can unplug and plug the device while the device is running without interrupting any services. Question number 3. What are two descriptions of three-tier network topology? Choose two options. And the options are option A, the core and distribution layers perform the same functions. Option B, the access layer manages routing between devices in different domains. Option C, the network core is designed to maintain continuous connectivity when devices fail. Option B, the core layer maintains wired connections for each host. And option E, the distribution layer runs layer 2 and layer 3 technologies. So the two descriptions of the three-tier network architectures are: the first one is that the network core is designed to maintain continuous connectivity when devices fail. And the second description is that this distribution layer runs layer 2 and layer 3 technologies. So let me first go through the explanation. The explanation for option C is that the network core is designed to maintain continuous connectivity when devices fail. This is key characteristic of three-tier network topologies. The core layer is designed to be highly redundant and resilient, ensuring that the network can continue to function even if individual devices fail. And the second description, option E, the distribution layer runs layer 2 and layer 3 technology. The distribution layer is responsible for routing traffic between the core and the access layer. It typically runs both layer 2, that is VLANs, MAC addressing, and layer 3, that is IP routing protocols, to perform its functions effectively. And this is the diagram of the three-tier network architecture. So we have the access layer, the distribution layer, and the core layer. So as we said that the core layer is designed to maintain continuous continuity of services even if individual devices fail or individual link fail. So what does this mean? That this device is connected to both the core devices. So let's suppose if this link fails and this device wants to communicate, so let me go back, communicate with this device, this one, it can still utilize this link and the communication won't be interrupted. So the core layer is thus designed to withstand the individual link or device's failure. And the second is that the distribution layer runs both layer 2 and layer 3 technology. So below this line, you can say that this is layer 2 technology where these devices are connected through VLANs, and you can further say that this is a trunk port that carries multiple VLAN. And above this, you can say that here the distribution layer is connected to the core through layer 3. So this way we can say that the distribution layer runs both the layer 2 and layer 3 technology. Question number 4. An engineer observes high usage on the 2.4 GHz channels and low usage on the 5 GHz channels. What must be configured to allow clients to preferably use 5 GHz access points? In the options are option A, 3 anchor round clients, option B, 11 ACMU MIMO, option C, OEAP split tunnel, and option D, client based select. And the correct option is the option D, client based select. So what is client based select? To optimize wireless network performance, enabling client based select encourages dual band capable clients to favor the less crowded 5 GHz frequency over the 2.4 GHz band. This helps balance traffic between both frequency ranges, improving overall efficiency and reducing congestion on the 2.4 GHz channels. Question number 5. Refer to the exhibit. This is the exhibit. Which command must be executed for interface gigabit 1/1 on switch 1 to become a trunk port if gigabit 1/1 on switch 2 is configured in desirable or trunk mode? So the question is that this link is configured as desirable or in trunk mode. So what must be configured on switch 1 for this link so that the Ethernet link is configured so that this link becomes trunk. And the options are option A, switch mode port trunk, option B, switch port mode dot one dash tunnel, option C, switch port mode dynamic auto, and option D, switch port mode dynamic desirable. And the correct option is that for the interface gigabit 1/1 on switch 1 to become trunk, we should configure the command switch port mode dynamic auto. And why is that? The explanation is that when a port is configured with dynamic auto, it will passively wait for the other side to initiate the trunking process. So the port on switch 1 will wait passively for the switch 2 to initiate the trunking process. So since switch 2 is set to be either desirable or trunk mode, switch 1's port in auto mode will agree to form a trunk link. So since we know that the port on switch 2 is already configured to be in desirable or trunk mode, so this port will initiate the process, and the port on switch 1 is in dynamic auto mode, it will accept the process, and thus this port will become trunk. Question number 6. What is the function of TFTP in network operations? And the options are option A, transfers a backup configuration file from a server to a switch using a username and password. Option B, transfers files between file systems on a router. Option C, transfers a configuration file from a server to a router on a congested link. And option D, transfer iOS images from a server to a router for firmware upgrades. And the correct option is option D, transfers iOS images from a server to a router for firmware upgrades. So this is a screenshot of a TFTP application, or you can say server application. This is how you can see that here this may be a router IP, and this is the file transfer in progress to this server, and this is the status of the file being transferred. This is the server IP from where the file is being transferred, and this is the directory. You can change the directory to the file where it is located. So this is very single application and simple setup used to transfer the firmware images from your laptop or from your server to the switches or to the routers. Question number 7. A network engineer must create a diagram of a multi-vendor network. Which command must be configured on the Cisco devices so that the topology of the network can be mapped? And the option are option A, Cisco config LLDP run. Option B, the command is CDP run. Option C, CDP enable. And option D, flow sampler map topology. And the correct command to map the network topology on the Cisco device is LLDP run. So these are the some of the commands that you can run on the Cisco switch regarding the LLDP protocol. You can run the command LLDP run. You can disable or remove this command. You can also disable the transmission or reception of the LLDP packets. And once you configure it, you can check the status of LLDP through these commands. Through these commands, you can show the LLDP configuration. You can show the neighbors that are being discovered through LLDP, and you can see the details of the neighbors that are discovered through this LLDP protocol. Question number 8. When a wireless LAN with WPA2 PSK is configured in the wireless LAN controller GUI, what format is supported? And the options are option A Unicode, option B base 64, option C decimal, and option D ASCII. And the correct option is the option D ASCII format. And this is a screenshot from a wireless LAN GUI. As you can see that we are using WPA2 and we have selected the PSK, and in the PSK format we can see the ASCII, and these are the ASCII characters that are typed. So in wireless LAN WPA2 using PSK mode, the ASCII format is supported. Question number 9. When deploying syslog, which severity which severity level logs informational messages? So these are different severity levels of logs. So what is the informational messages severity? And the options are option A 0, option B 2, option C 4, and option D 6. And the correct option is option D 6. So here is the quick reference for syslog severity level. So 0 is for emergency, 1 is critical, 1 is alert, 2 critical, 3 for errors, 4 is for warning, 5 is for notice, and 6 is for information as in this case, and 7 is for debug. Question number 10. Which protocol does an access point use to draw power from a connected switch? And the options are option A Internet Group Management Protocol, option B Adaptive Wireless Path Protocol, option C Cisco Discovery Protocol, and option D Neighbor Discovery Protocol. And the correct option is option C CDP or Cisco Discovery Protocol. So the Cisco Discovery Protocol CDP is a proprietary protocol used by Cisco devices to discover neighboring devices on a network. It also provides information about the capabilities of these devices, including the power capabilities of switches. Access points can use CDP to request power from a connected switch. 7. Refer to the exhibit. To which device does router 1 second send packets that are destined to host 10.10.13.165? And the options are option A router 2, option B router 3, option C router 4, and option D router 4. We have the router R1 over here, and this is the routing table of R1. So in order to reach this host, that is 10.10.13.165, where would router 1 send the packets? To which router will R1 send the packets, to R2 or 3 or 4? Or first look at the routes, and we will try to find out the routes that contains this host address. So this 10.10.13.0/25, now this range is from 0 to up to 1 to 7. So this route is excluded. Again, this route is also excluded because this range is up to 144 or 143. Again, this is again excluded. It is up to 159. This route actually contains the host address 165 10.10.13.125, and the route is 10.10.13.160/29, and it is accessible via the hop 10.10.10.5, and the interface is gigabit Ethernet 0/1. So where is the 10.10.10.5? We need to find this hop, and this hop is basically this one, 10.10.10.4/30, means that we have .5 address over here. That's why the router R1 will send the packet to R3 in order to reach this host, that is 165. So the correct option is router R3, and this is the again the explanation that this route is 160/29 is accessible with via this hop 10.10.10.5. This the subnet of this hop is /29, and the range is from 160 up to 167. So this definitely include the host 165. So that's why the router R1 will send the packet to R3 in order to reach 165. Question number 12. Which networking function occurs at the data plane? And the options are option A, forwarding remote client server traffic. Option B, facilitates spanning tree elections. Option C, processing inbound SSH management traffic. And option D, sending and receiving OSPF hello packets. And the correct option is that the function that occurs at the data plane in these options is the forwarding remote client and server traffic. So the data plane is responsible for forwarding packets or frames based on decision made by the control plane. It means that decision or the routing protocol calculations are made at the control plane, and then these decisions are basically installed inside the forwarding or data plane where the packets are readily forwarded. So the other options relate to control plane functions. So the like the management of management traffic and protocol exchanges, these are control plane functions. Question number 13. Which two tasks must be performed to configure an NTP to a trusted server in client mode on a single network device? We are talking about network time protocol, and the options are, you have to choose two options. Option A, enable NTP authentication. Option B, verify the time zone. Option C, disable NTP broadcast. Option C, specify the IP address of the NTP server. And option E, set the NTP server private key. And the correct options are option A, enable the NTP network time protocol authentication. And the second correct option is that specify the IP address of the NTP server. So to configure NTP in client mode to a trusted server or a network device, the following two tasks must be performed. Number one, enable NTP authentication. This ensures that the NTP client only accepts time updates from a trusted server by using authentication keys. And the second option is that specify the IP address of the NTP server. The client needs to know the specific NTP server's IP address to synchronize its time with it. Question number 14. Where does a switch maintain DHCP snooping information? And the options are option A, in the MAC address table. Option B, in the CAM table. Option C, in the binding database. And option D, in the frame forwarding database. And the correct option is option C, in the binding database. So a switch maintains DHCP snooping information in the binding database. This database contains details about IP address and MAC address bindings, as well as the associated VLAN and interface information. Question number 15. Refer the exhibit. This is the exhibit. Here we have a configuration on switch 1. That is the configuration of Ethernet gigabit 01. So we have interface gigabit 01. It is switch port access VLAN 11. And we have switch port trunk allowed VLAN 1 to 10. So these VLAN are allowed on the interface 01 in trunk mode. Switch port trunk encapsulation.1 queue. and switch port trunk native VLAN 5. So we have configured native VLAN as VLAN 5 and switch port mode trunk speed 1000 Mbps and it is in full duplex mode. The question is that what action is expected from switch 1 when the untagged frame is received on the Gigabit Ethernet 0/1 interface. We are talking about this interface that contains this configuration. When this interface receives an untagged frame, what would be the behavior of the switch and the interface? And the options are option A, the frame is processed in VLAN 5. Option B, the frame is processed in VLAN 11. Option C, the frame is processed in VLAN 1. And option D, the frame is dropped. And the correct option is, since we are talking about the untagged frame, and untagged frame is always processed in the native VLAN, and native VLAN is VLAN 5, so the frame is processed in VLAN 5. So based on this configuration, when an untagged frame is received on the Gigabit Ethernet 01 interface, it will be processed in the native VLAN, which is VLAN 5. Question number 16, refer the exhibit. Again, this is the exhibit. A network administrator assumes a task to complete the connectivity between PCA and the file server. So, here, like this is PCA and this is file server, and we want to ensure connectivity between them, and there is PCA is connected to switch A while PCB is connected to switch B. Server switch A and switch B have been partially configured with VLAN 10, 11, 12, and 13. What is the next step in the configuration? We have this configuration on switch A. We have VLAN 10, 11, 12, 13, and interface Gigabit 01. This interface is configured as trunk, and VLAN 10 to 12 are allowed on this trunk port. This is switch A. And on the interface Gigabit 04, we are talking about this interface here. The PCA is connected. This interface is in switch port access VLAN 13 switch port mode access. So this interface is in VLAN 13. It means that this PC is connected to VLAN 13. And on the switch B, again we have interface Gigabit Ethernet 01 switch mode port trunk. Again, this port is in trunk mode. Interface Gigabit Ethernet 003. This is 03 interface to which the file server is connected. And again, the file server is placed in VLAN 13 in the same manner as the PCA. So this is the configuration. In order for PCA to communicate with the file server, both are in VLAN 13. What configuration must be done on these two switches so that PCA can communicate with file server? And the options are option A, add PCA to VLAN 10 and the file server to VLAN 11. Option B, add VLAN 13 to the trunk links on switch A and switch B for VLAN propagation. Option C, add a router on a stick between switch A and switch B, allowing for inter-VLAN routing. And option D, add PCA to the same subnet as the file server, allowing for intra-VLAN communication. And the correct option is option B, add VLAN 13 to the trunk links on switch A and switch B for VLAN propagation. So, since these both devices, the file server and PC are in VLAN 13, we need to propagate VLAN 13 on this trunk link, that is Gigabit 0/1. So VLAN 13 must be added to this trunk link. Here we can see that we have added only VLAN 10, 11, 12. We'll also need to add VLAN 13 here, as well as we need to add VLAN 13 to this link as well, and this will do the job. Question number 17. Which goal is achieved by the implementation of private IP version 4 addressing on a network? And the options are Sorry, let me rephrase the question. So, which goal is achieved by implementation of private IP version 4 addressing on a network? The private IPv4 addresses are RFC 1918 addresses that we have studied already. These are 10/8, 192.168/16, and 172.16/12. These are the private IPv4 address scheme. And what is the purpose of these using these addresses? And the options are: option A provides an added level of protection against internet exposure. Option B provides a reduction in size of the forwarding table on network router. Option C allows communication across the internet to other private networks. And option D allows servers and workstations to communicate across public network boundaries. And the correct option is that they are basically able to provide an added level of protection against internet exposure. So let me explain how does this work. So let's suppose this is a router and one link of this is connected to basically ISP and the internet. So this is the internet, while on the other link we have, let's suppose, this switch, and to this switch we have client that are connected over here. This is basically LAN, and these clients have, let's suppose, IP addresses 192.168.1.10. Let's suppose this client and this client have IP address of 192.168.1.1. Let's suppose 1.20. Okay, let me get back a bit. So these IP addresses basically are not routable over the internet. This router will have a public IP address, let's suppose 8.10.9.11. Okay, so whenever the private IP addresses want to access the internet, the traffic will come to this router and the private IP addresses will basically be translated to this 8.10.9.11. When a packet moves to the internet, the source address will be this one. The destination may be any internet destination such as YouTube, Google. That's why we say that these addresses are private, they are not exposed over the internet, and this gives us an added security. Explanation is that the private IP version 4 addresses defined in RFC 1918 are not routable on the internet. This means devices using private addresses are not directly exposed to external threats from the internet, providing a layer of security. While there are secondary benefits such as the conservation of public IP addresses and reduction of forwarding table size, the main purpose is to enhance security by preventing direct access from external networks. Question number 18, refer to the exhibit. This is the exhibit. Router R1 is running three different routing protocols. Which route characteristic is used by the router to forward the packets when it receives for destination 172.16.32.1? In the option are: option A longest prefix, option B metric, option C cost, and option D administrative distance. So this is R1. This is the routing table of R1. And the routing table contains routes from three different routing protocols. And the routes are 32.0/27/19/24. So basically, this host is accessible through all these three routes. So which route will be selected and why? These are the different criteria on which you can select route: the longest prefix, metric, cost, and administration distance. And the correct option is that the first most criteria to select a best route is the longest prefix. So in this case, which route will be selected? This one. Since this route has this longest prefix, that's why this route will be selected. Let me get to the explanation and explain further this concept. So this is very important. You may expect multiple questions on the route selection in your exam. So please pay close attention. So look at the prefix length first. So when selecting a route, first of all, look at the prefix length. If you have one that is longer than the rest, choose that as an answer, such as in this case. If there is more than one with the same longest prefix, if you have two routes with the similar prefix length, then you should go to the next criteria, move over to the AD, that is administrative distance, and pick the route with the lowest administrative distance. Once again, if you have duplicate administrative distances in the routes, then you should move to the next criteria, that is the metric. So in this example provided, the routes have the following administrative distances. So this route has this 90, and this the second is 110, and the third one is 120. So each routing protocol has a certain administrative decisions, such as 90 is for EIGRP, 110 is for OSPF, and 120 is for BGP. A quick question: what is the administrative distance for static route? I think it is 10. And in the example provided, the routers have the following metrics. So these are the metrics. So let me get back. So these first numbers, these basically shows the administrative distances, while the second number, they are the metrics. So in our case, we chose the route at the first criteria, that is the longest prefix, since this route is the longest prefix with no other competitor. So if we had two routes, let's suppose if we had 27 over here as well, then we would have moved to the administrative distance, and again we would have selected the same routes because the AD of this route, that is 90, is less than 110. And the third criteria would have been the metric. The route with the lowest metric would be selected first. So I hope you people get the concept. Question number 19. What are two benefits of network automation? Choose two. And the options are: option A, reduced operational costs; option B, reduced hardware footprint; option C, faster changes with more reliable results; option D, fewer network failures; and option E, increased network security. And the correct options are option A, reduced operational costs, and the second correct option is option C, faster changes with more reliable results. The explanation is that the two benefits of network automations are: number one, reduced operational costs. Automating network tasks can decrease the need for manual intervention, leading to lower labor costs and more efficient use of resources. The second correct option is the faster changes with more reliable results. So network automation allows for quicker deployment of changes and configuration, reducing the potential for human error and increasing the reliability of the results. Question number 20. When a site-to-site VPN is used, which protocol is responsible for the transport of user data? And the options are: option A, IKE version 2, option B, IKE version 1, option C, IPsec, and option D, MD5. And the correct option is option C, IPsec, that is IP security. So IPsec, that is Internet Protocol Security, is used to secure Internet Protocol communication by authenticating and encrypting each IP packet in a communication session. It provides the necessary framework to protect user data over the VPN. IKE version 1 and IKE version 2, that is Internet Key Exchange version 1 and version 2, are protocols used to set up the secure communication channels and manage the encryption keys, but they do not directly transport user data. MD5 is a hashing algorithm used for integrity checks but is not responsible for data transport. Question number 21. What is the primary function of a layer 3 device? And the options are option A to analyze traffic and drop unauthorized traffic from the internet. Option B to transmit wireless traffic between hosts. Option C to pass traffic between different networks. And option D forward traffic within the same broadcast domain. And the correct option is that the layer 3 device is basically used to pass traffic between different networks, and this is performed through routing. When you have different networks, you need a router or routing to exchange packets between these two different networks. By different networks, we mean networks having different IP subnets, such as 192.168.1.0/24 and 10.10.10.0/24. These are two different networks. In order to make communication between these networks, you need routing or a layer 3 device. So layer 3 devices operate at the network layer of the OSI model, where they manage routing of packets between different IP networks. They use IP addressing to determine the best path for forwarding traffic across various networks. While layer 3 devices can analyze and filter traffic related to option A and may interact with wireless traffic that is related to option B, their main purpose is routing between different networks. Option D refers to functions that are typical of layer 2 devices, like switches that operate within the same broadcast domain. Question number 22. Router A learns the same route from two different neighbors. One of the neighbor routers is an OSPF neighbor and the other is an EIGRP neighbor. What is the administrative distance of the route that will be installed in the routing table? And the options are option A 20, option B 90, option C 110, and option D 115. So we studied the administrative distance of OSPF and EIGRP a while ago. So the uh, protocol with the lowest administrative distance will be selected. That's why the correct option is 90, and 90 is the administrative distance from EIGRP, while 110 is the administrative distance of OSPF. So in this scenario, router A learns the same route from two different neighbors using different routing protocols that are OSPF and EIGRP. Each routing protocol has a predefined administrative distance that determines its trustworthiness compared to two other protocols. The administrative distance for the relevant protocols are for OSPF, that is Open Short Test Path First, it is 110, and for EIGRP Enhanced Interior Gateway Routing Protocol, it is 90. Since EIGRP has a lower administrative distance of 90 compared to OSPF of 110, the route learned from the EIGRP neighbor will be preferred and installed in the routing table. Question number 22. When the active router in an HSRP group fails, what router assumes the role and the forwarding and forwards the packets? And the options are option A backup, option B standby, option C listening, and option D forwarding. And the correct option is option B standby. The standby router is the one designated to take over the forwarding role in case the active router fails. It monitors the active router and will take over as the active router if it detects a failure. The backup terminology is not used in HSRP. The standby router is the correct term. The listening state refers to a router that is aware of the HSRP group but is not currently the active or standby router. Forwarding is not a specific state in HSRP terminology but refers to the action of sending packets when a router is active. Question number 24. Which two protocols must be disabled to increase security for management connection to a wireless LAN controller? Choose two options. And the options are option A telnet, option B SSH, option C HTTP, and option D HTTPS, while option E is TFTP. So we are talking about disabling two of the protocols over here to increase the security, and the correct options are option A telnet. It is because the traffic sent through telnet is in plain text, it is not encrypted, and again in the same manner the traffic of HTTP is also not encrypted, it is in the plain text. The secure version of telnet is basically SSH. In SSH the traffic is encrypted, while the secure alternative of HTTP is HTTPS. Question number 25. When a client and server are not on the same physical network, which device is used to forward requests and replies between client and server for DHCP? That is Dynamic Host Configuration Protocol. And the options are option A DHCP Relay Agent, option B DHCP Server, option C DHCP Discover, and option D DHCP Hopper. And the correct option is option A DHCP Relay Agent. So when a client and server are not on the same physical network, a DHCP relay agent is used to forward DHCP requests and replies between the client and the DHCP server. The relay agent acts as an intermediary, translating the DHCP messages between the client and server and ensuring that they are properly routed. So this is how the DHCP relay agent works. So we have a client which is on a network 192.168.2.0, while the DHCP server is on a different network 192.168.1.0, and they are also physically separated. So a DHCP relay agent between them is needed so that the request and responses between the client and the server are propagated. Question number 26. Protocol requires authentication to transfer a backup configuration file from a router to a remote server. The options are option A DTP, option B FTP, C SMTP, and option D TFTP. And the correct option is option B FTP File Transfer Protocol. And the explanation is that the file transfer protocol requires authentication, that is username and password, to transfer files such as backup configuration files between a router and a remote server. DTP, that is Dynamic Trunking Protocol, is used to negotiate trunking between switches. SMTP, that is Simple Mail Transfer Protocol, is used for sending emails. And TFTP, that is Trivial File Transfer Protocol, does not require authentication but is less secure. Question number 27. An engineer must configure traffic for a VLAN that is untagged by the switch as it crosses a trunk link. Which command should be used? And the options are option A switch port trunk allowed VLAN 10, B switch port trunk native VLAN 10, option C switch port mode trunk, and option D switch port trunk encapsulation .1 Q. And the correct option is option B switch port trunk native VLAN 10. So the command switch port trunk native VLAN 10 is used to configure the native VLAN for a trunk link. The native VLAN is untagged as it crosses a trunk link while other VLANs are tagged. This command ensures that traffic for VLAN 10 is sent untagged across the trunk. Option A, that is switch port trunk allowed VLAN 10 specifies which VLANs are allowed on the trunk but does not affect whether the VLAN is tagged or untagged. Option C, switch port mode trunk simply sets the port to trunk mode. And option D, switch port trunk encapsulation.q sets the encapsulation type but does not address native VLAN configuration. Question number 28. Why does a switch flood a frame to all ports? And the options are option A, the frame has zero destination MAC addresses. Option B, the source MAC address of the frame is unknown. Option C, the source and destination MAC addresses of the frame are the same. And option D, the destination MAC address of the frame is unknown. And the correct option is that a switch floods a frame to all ports when the destination MAC address of the frame is unknown. So the explanation is that a switch floods a frame to all ports when the destination MAC address is not present in its MAC address table. This is because the switch does not know which port to forward the frame to, so it sends the frame to all ports except the one it was received on. Once the switch learns the destination MAC address by observing the response, it will update its MAC address table and forward future frames to the correct port. Question number 29. A network administrator enabled port security on a switch interface connected to a printer. What is the next configuration action in order to allow the port to learn the MAC address of the printer and insert it into the table automatically? And the options are option A, enable dynamic MAC address learning. Option B, implement static MAC addressing. Option C, enable sticky MAC addressing. And option D, implement auto MAC address learning. And the correct option is option C, enable sticky MAC addressing. And the explanation for this option is that enabling sticky MAC addressing allows the switch port to dynamically learn the MAC address of the connected device, in this case the printer, and automatically add it to the running configuration as a secure MAC address. This way the MAC address is learned dynamically, but once it is learned, it is stuck in the configuration to ensure the device's MAC address is secure. A and D are incorrect because there are no specific commands for dynamic or auto MAC address learning in this context. Sticky MAC address serve this purpose. Option B is incorrect because static MAC addressing would require manually entering the MAC address into the configuration, not learning it dynamically. Question number 30. Where is the interface between the control plane and the data plane within the software-defined architecture? And the options are option A, control layer and the infrastructure layer. Option B, application layer and the infrastructure layer. Option C, application layer and the management layer. And option D, control layer and the application layer. So the interface between control and data plane is at the control layer and the infrastructure layer. So in a software-defined architecture, the control plane is responsible for managing the network's routing, forwarding, decision, and policies, while the data plane handles the actual forwarding of packets. The interface between the control plane and the data plane is found between the control layer, which contains the control logic, and the infrastructure layer, which includes the networking hardware that forwards the data. This separation allows for centralized management of network devices while distributing the data forwarding across multiple devices. And this is how the SDN architecture looks like. So we have this infrastructure layer, and data plane basically lies over here. And this control layer where the control plane lies. So the interface between the control plane and data plane is actually it is the between the control layer and the infrastructure layer.